I regret that I am unable to access external websites and therefore cannot provide specific details from the NEMA forum link you provided. However, I can offer general information on electrical standards and practices. Electrical work is governed by codes and standards designed to ensure safety and proper functionality. In the United States, the National Electrical Code, or NEC, is a widely adopted standard for electrical installations. It's important to consult the latest edition of the NEC for specific requirements in your jurisdiction. Understanding fundamental concepts like voltage, amperage, resistance, and power is crucial. Voltage is the electrical potential difference, measured in volts, that drives current through a circuit. Amperage is the measure of electrical current flow, measured in amps. Resistance, measured in ohms, opposes the flow of current. Power, measured in watts, is the rate at which electrical energy is used. Ohm's law describes the relationship between voltage, current, and resistance. Voltage equals current times resistance, or volts equals amps times ohms. Power is calculated as voltage times current, or watts equals volts times amps. Proper grounding is essential for electrical safety. Grounding provides a low resistance path for fault current to flow back to the source, causing the overcurrent protection device, such as a circuit breaker or fuse, to trip and interrupt the circuit. This helps to prevent electrical shock hazards. Grounding systems typically consist of a grounding electrode, such as a ground rod or ground plate, connected to the equipment grounding conductor system. The equipment grounding conductor system provides a path for fault current from non-current carrying metal parts of electrical equipment back to the grounding electrode. Bonding is the process of connecting non-current carrying metal parts together to create a low impedance path for fault current. Bonding helps to ensure that all metal parts are at the same potential, reducing the risk of electrical shock. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when the current in a circuit exceeds the ampacity of the conductors. Short circuits occur when there is a low resistance path between two conductors. Circuit breakers are automatic switches that trip and interrupt the circuit when an overcurrent is detected. Fuses are overcurrent protection devices that contain a fusible link that melts and opens the circuit when an overcurrent occurs. The ampacity of a conductor is the maximum current, in amps, that it can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by its size, insulation type, and installation conditions. The NEC provides tables that list the ampacity of various conductors under different conditions. Proper wiring methods are essential for safe and reliable electrical installations. Conductors must be properly sized for the intended load and protected from physical damage. Wiring must be installed in accordance with the NEC and other applicable codes and standards. The electrical boxes are used to enclose electrical connections and provide mechanical protection for wiring. Electrical boxes must be properly sized for the number of conductors and devices they contain. Conduit is a raceway used to protect electrical wiring. Conduit can be made of metal or non-metallic materials. Different types of conduit are suitable for different applications. Electrical panels are used to distribute electrical power to different circuits. Electrical panels contain circuit breakers or fuses that protect each circuit from overcurrents. Electrical panels must be properly sized for the intended load and installed in accordance with the NEC. Arc flash is a dangerous electrical hazard that can occur when there is a fault in an electrical system. Arc flash events can generate intense heat, light, and pressure, causing serious burns, injuries, and even death. Arc flash hazard assessments are used to determine the potential arc flash hazard at a particular location. Personal protective equipment, or PPE, is used to protect workers from arc flash hazards. PPE includes items such as arc-rated clothing, gloves, and face shields. Lockout/tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. Lockout/tagout involves disconnecting the equipment from its power source and applying a lock and tag to the disconnect switch. Electrical safety training is essential for all workers who work with or around electricity. Electrical safety training should cover topics such as electrical hazards, safe work practices, and the use of PPE. A NEC contains many tables that are used to determine conductor ampacity, conduit fill, and other electrical design parameters. For example, NEC Table 310.15b16 provides the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current carrying conductors in raceway, cable, or earth directly buried, based on ambient temperature of 30 degrees Celsius. Adjustments and corrections must be made to these ampacities for ambient temperatures other than 30 degrees Celsius and for more than 3 current carrying conductors in a raceway or cable. NEC Table 310.15b3 provides adjustment factors for more than 3 current carrying conductors in a raceway or cable. NEC Table 310.15 CON provides correction factors for ambient temperatures other than 30 degrees Celsius. NEC Chapter 9 contains tables that provide information on conduit fill, box fill, and other electrical design parameters. For example, NEC Table 4 provides the dimensions and percent area of conduit and tubing. NEC Table 5 provides the dimensions of insulated conductors and fixture wires. NEC Table 314.16 provides the number of conductors permitted in outlet device and junction boxes. Electrical calculations are used to determine the proper size of conductors, overcurrent protection devices, and other electrical equipment. Electrical calculations must be performed in accordance with the NEC and other applicable codes and standards. Voltage drop is the decrease in voltage along a conductor due to the resistance of the conductor. Voltage drop can affect the performance of electrical equipment. The NEC recommends that voltage drop not exceed 3% for branch circuits and 5% for feeders. Short circuit current calculations are used to determine the amount of current that will flow during a short circuit. Short circuit current calculations are used to select the proper size of overcurrent protection devices. Ground fault circuit interrupters, or GFCIs, are used to protect people from electrical shock. GFCIs detect ground faults and interrupt the circuit within milliseconds. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or ASIs, are used to protect against arc faults. ASIs detect arc faults and interrupt the circuit. ASIs are required in certain locations, such as bedrooms. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning, utility switching, and other events. SPD diverts surge current to ground, protecting electrical equipment from damage. Harmonic distortion is a distortion of the sinusoidal wave from a alternating current. Harmonic distortion can be caused by nonlinear loads, such as electronic equipment. Harmonic distortion can cause overheating of electrical equipment and can interfere with the operation of other equipment. Power factor is a measure of how effectively electrical power is being used. A low power factor indicates that a large portion of the current is not being used to do useful work. Power factor correction can improve the efficiency of electrical systems. Energy efficiency is the practice of using less energy to perform the same task. Energy-efficient electrical equipment can save money and reduce environmental impact. Electrical inspections are performed to ensure that electrical installations are in compliance with the NEC and other applicable codes and standards. Electrical inspections are typically performed by local building officials. Electrical permits are required for many types of electrical work. Electrical permits ensure that electrical work is performed in accordance with the NEC and other applicable codes and standards. The NEC is updated every 3 years. It is important to consult the latest edition of the NEC for specific requirements. Many resources are available to help you understand electrical standards and practices. These resources include books, websites, and training courses. Consulting with a qualified electrician is always recommended for any electrical work. They possess the knowledge and experience to ensure the work is done safely and correctly, adhering to all applicable codes and regulations. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for any electrical work. Failure to comply with electrical codes and standards can result in serious injury, death, and property damage. Remember, safety is paramount when working with electricity. Always take the necessary precautions to protect yourself and others from electrical hazards. Ensure you understand the specific requirements of the NEC and other applicable codes and standards in your jurisdiction. By following these guidelines and seeking professional help when needed, you can ensure safe and reliable electrical installations. Firstly, understand the fundamental electrical concepts: voltage, amperage, resistance, and power. Secondly, ensure proper grounding for electrical safety and fault current path. Thirdly, use appropriate overcurrent protection devices like circuit breakers and fuses. Fourthly, apply correct wiring methods and conductor sizing based on load. Fifthly, implement arc flash hazard assessments and use personal protective equipment. Sixthly, follow lockout and tagout procedures during maintenance. Seventhly, take electrical safety training to know all those concepts. Eighthly, consult NEC tables for design parameters like ampacity. Ninthly, perform voltage drop and short circuit current calculations. Tenthly, use ground fault and arc fault circuit interrupters for protection.